Oh, we're getting there. We're getting to the end of the semester. We're going to look at 5.4. Lesson 5.4 says we're going to learn the sum and difference formulas for the trig functions. So you can see at the top of the page here, we've got several. We have 6 involving sine, cosine, and tangent. So what these formulas give us is the ability to figure out the exact value of different angles. We understand from the unit circle we can do 30, 45, 60, 90, all of the easy angles. But what we're going to be able to do with sum and difference formulas is find more complicated angles. So let's look at example number 1. Very first one, it says find the exact value of 1, the cosine of 75, and 2, the sine of pi over 12. So for 75, we're going to consider our table up here. We've got cosine, so we're going to be looking at the 2 cosine functions, and we have subtraction and difference. Well, I know that cosine simply 30 plus 45 degrees. I know that's a simple sum for 75. So we're going to take that fact and we're going to say that the cosine of 75 is the same as the cosine of 30 plus 45. Referring back to the table, this is going to take some studying and some good notes. We have a sum formula, and so we're going to break u and v into our 2 angles that we talked about. U plus v has to equal our 75. So we have cosine u plus v. It's going to be the cosine of u times the cosine of v, and then it's the difference. You're going to start to see these patterns. U plus v for cosine is a difference of the 2 products. So the second part of our problem is sine u, sine v, and we're going to do the same thing there. So back to our problem, we're simply going to input these values, and we know that the cosine of 30 from our unit circle, we've got square root of 3 over 2, 45 is square root of 2 over 2. The sine values of 30 and 45, same thing, 1/2 and square root of 2 over 2. So we're going to simplify on the left side. We get combining radicals, we get square root of 6 over 4 on the left side. On the right side, we get square root of 2 over 4, and we would combine those as such. Square root of 6 minus square root of 2 all over 4. Those cannot be consolidated anymore. Part B of example 1 says now we're going to find pi 12ths. We're going to think about our unit circle again. Which radians are easy to work with? We have 4 pi over 12 minus 3 pi over 12. That's how I look at those, and that gives us 1 pi over 12. So the pi thirds and pi fourths, we're going to take the sine. This is a difference problem, so we're going to look back up here, the difference function for sine. We're right here, sine u minus v. Now this is a little different, is sine u cosine v. And notice that the subtraction is going to follow with the sine functions. Minus cosine u sine v. Here's how I remember it. This is a sine formula, so sine comes first. Sine u cosine v. It's the difference of that. And cosine u sine v. So let's go ahead and take that down here. Our 2 angles are pi thirds and pi fourths. We're going to plug that into our formula. Sine u times cosine v. And it's subtraction, just as it is up here, cosine u sine v. We're going to take those values from our memory, or our unit circle, and simplify, and we can see that we get the exact same thing. Square root of 6 minus the square root of 2 over 4. I want you guys to try problem number 9 and come back and check your solutions. Well, on first glimpse, I know what you're thinking. The cosine of 240 minus 0 is simply the cosine of 240. This is simply a way of proving that our formulas are truly at work for us. So the subtraction, the cosine, the difference cosine, remember, is cosine u cosine v plus sine u sine v. So we're going to go ahead and plug that in. cosine u, cosine v, plus sine u, sine v. And we know the sine of 0 to be 0, making this entire product 0. We know cosine of 240 is negative 1/2, and the cosine of 0 is simply 1. And that gives us our solution. Cosine of 240 minus 0 is the cosine of 240, which is negative 1/2. So u is existing in the first quadrant between 0 and pi halves, and we know that the sine of u is 4/5. So we can conclude then that here the cosine of u is 3/5. Thinking about our unit circle. So we know cosine u and we know sine u, and we're going to be using one of our sum theorems. So now between pi halves and pi, we are in the second quadrant over here, and we know cosine is cosine of v now. This was u. The cosine of v is negative 12/13. So we can conclude from that our sine of v is 5/13. And sine is positive in the second quadrant. From there, we're going to go ahead and use the information that we have just figured out. We've got cosine v, sine v. We've got cosine u, sine u, and we're simply going to plug those into our formula. Our formula, sine u plus v, is sine u cosine v plus cosine u sine v. And we're just going to input our values. Sine u, 4/5, cosine v, negative 12/13. And we're going to add to that the cosine of u, which we found to be 3/5. And we're going to multiply that by the sine of v, which is 5/13. Getting our exact angle for this situation. Do that multiplication, and we get negative 48/65 plus 15/65. We get negative 33/65. And so problem 49 is what I want you guys to try. It says find the exact value of the trig expression. So we're doing one of our sum or difference expressions. And again, I misspoke in the first part. We were looking for an exact value, not an angle. We already had the angles. We were talking about angle u and angle v. We were talking about the sum of those two. And that's what we found in negative 33/65. So problem 49, you guys please do this one. It wants the exact value of the sine u plus v, given that sine of u is 5/13 and the cosine of v is negative 4/5. Both of them are in quadrant 2. Try that one and come back and check your answer. So studying the information that we're given, sine of u is 5/13. That allows us to come up with the cosine of u, which is negative 12/13. And over here, the cosine of v is negative 4/5. So we know the sine of v to be 3/5. So we can now just plug into our formula the sine of u plus v. That's equal to sine u cosine v plus cosine u sine v. So we're simply going to write those out. Sine u 5/13 times negative 4/5. Cosine u negative 12/13 times sine v 3/5. You can do some fun mental math. Negative 20/65 plus negative 36/65. We should come up with negative 56/65. So with our 4 minutes left on this recording, we're going to try to get through example 3. It says to write this as an algebraic expression. Well, let's go back to our inverse, tangent, and cosine, and all of our inverse trig functions. We see that this fits cosine of u plus v, so we can name u as the arctangent of 1. Let u be the angle. The tangent of this angle is 1. We know tangent is opposite over adjacent. We use Pythagorean theorem. We find our hypotenuse to be square root of 2. And likewise with arc cosine x, cosine of some angle v is equal to x. That's adjacent over hypotenuse. And we find the other side, our missing side, our opposite side, as 1 square root of 1 minus x squared. So we're looking at our sum of cosine u plus v. We realize we have cosine u. We were given that in arc cosine x. Cosine is adjacent over hypotenuse. So the cosine of u is 1 over square root of 2, which is just the square root of 2 over 2. And the cosine of v is adjacent over hypotenuse, which is simply x. From that, we're going to subtract the sine of u, again, opposite over hypotenuse, so square root of 2 over 2, and the sine of v, opposite 1 minus x squared over 1. So in simplifying that, we get x square root of 2 minus the square root of 2 times the square root of 1 minus x squared, and that is all over 2. And you guys look at the example 3 in the book, and you can see that they've left the radical in the denominator, which is an absolute no-no, but they did it, so we're going to leave it. And I want you guys to try, from this example, I want you to try number 57 and come back and check. So this problem 57 is asking us to find the exact value of sine of arc sine x plus arc cosine x, and we see that falls within our pattern sine u plus v. So we're gonna name our first angle arc sine of x. We're gonna call that u. This is saying the sine of some angle is x, so the opposite over the hypotenuse, and from that we can deduce that our final side is 1 minus x squared, square root of that. The same thing, we're going to name this v. It says the cosine of some angle is x, so that's adjacent over hypotenuse, and we can see that then our opposite side is similar to the one found for angle u. And we can take these two values, cosine v is x, sine v is 1 minus x squared radical. So we're going to take those and plug them into sine u plus v, and that was sine u cosine v plus cosine u sine v. That looks like a bunch of gobbledygook. So we're gonna plug those in. Sine u is x, cosine v is x, and on this side we have cosine u 1 minus x squared, and we're going to multiply that by itself. So we end up with x squared plus 1 minus x squared, and that equals 1.